Okay. So the first one I think is pretty simple. Okay. The first one you do, the problem is x squared ln x dx. Right? We did this one in the before the class, before the test, exactly the same. Okay, you do integral parts. You let u equals ln x. That dv is x squared. So you do u, derivative u is x squared, and derivative of x squared is x cubed over 3, and plus, minus, like that. Okay. So then the derivative, antiderivative is going to be uv minus v du, so it's ln x times x cubed over 3, minus v du, which is 1 over x cubed over 3 dx. Okay. Then you reduce that is ln x cubed over 3 minus x cancelled out is x squared over 3 dx. So the final answer is going to be ln x3 over 3 minus x cubed over 3 over 3, and then 3 is 9 plus c. Most of the students, I think most of the students, almost everyone did this one right. The first one problem, not big trouble. Second one, find the area between y1 equals x power 4 and y2 equals x power 5, right? The second problem. And this one is pretty okay. You just need to draw the picture. And if you draw the picture, you can tell that x power 4 is, x power 4 is bigger. It's kind of like this. But x power 5 is kind of like small at the beginning, but it's increasing here. So this, first we find out the intersection points. Okay, so you just need to set up x power 4 equals x power 5, and you solve for x, and you solve for x equals 1. Sorry, 0 and 1, and then you know the boundary is 0 and 1. This is one of the problems in your quiz, test review. So what do we need to do? You find the area bounded by these two. So the area S equals, the top is, this is x power 4, and the bottom is x power 5. Okay, so your answer should be x power 4 minus x power 5 and dx from 0 to 1. And then, because the area formula is a to b fx minus gx dx, your final answer is going to be x power 5 over 5 minus x power 6 over 6 from 0 to 1, which is 1 over 5 minus 1 over 6, and is 1 over 30. Good, everyone? Most of you did it good on this one too. Okay? And number 3 is find the region. Some students have trouble with this one. Not everyone, but a few, several. Between 4x plus y squared equals 12 and x equals y. Okay. Basically, if you draw the picture of this one, this one is pretty simple. X equals y. So just draw a picture x equals y like this. Can anyone tell me what is the shape of the first equation? Can anyone tell me what's the shape of the first equation? What's the shape of this equation? Zijian? Or Lacey?
It's like almost a line, but it has a curve, and it's like the opposite of the x equals y. So it comes like this.
Okay, so if I change that into y squared equals negative 4x plus 12, then you can tell this is a parabola, open, left, right, up, and down. Which one? Left, right, up, or down?
Left.
Yeah, very good. Thank you very much. So it's open left. If you draw the picture, it's like this. If you use the graphing calculator to draw the picture, it probably only draw the upside, this part, the up part. Because if you take if you take solve for y, you should get positive and negative square root of negative 4x plus 12. And it has the top, it gives you this one, positive is this up, and bottom is this one. So now, if you do the fx minus gx, think about this. I have already given you a function, an area, using the fx minus gx in the second problem. Why do I give you another one and use the same method again? It should be a little bit different. So this one, you can use the fx minus gx like this way. But the thing is, you find the boundary of this one and this one is only up to here. You can only find to here because the boundary is this point to this point. If you do this point to this point, you only can get the thing here. Not after this point, this part, you don't have anything. Otherwise, you have to find this point again and do it again. If you do vertically, you can only get this part. Because this part, you have to do this point again. Like you have to do another time again on this area. Use the top minus, use this one minus this one. Use the fx minus gx again. Because this one only covers this part. Does it make sense? Okay. So, what I need to do, I cannot do that again. How do I cancel that? Okay. So, I cannot do that method to the vertical rectangle. I have to do the horizontal rectangle. For example, it's going to wait a minute. So first, I need to solve these 2 points. How do I solve the intersection points? You basically set up these two equations equals each other. Plug x equals y into here, so you can solve the equation. You can do x, replace y by x, replace x by y, either one is okay. So if I replace y by x, you have 4x plus x squared equals 12. Then x squared plus 4x minus 12 equals 0. Then you can solve x minus 2, x plus 6 equals 0. And x equals 2, x equals negative 6. And you also have y equals 2, y equals negative 6, because they're the same, x equals y. So now you have negative 6, and 2 positive 2. In this one, you are going to use the vertical line, the vertical way, this one. We actually did several examples in the class as well. So do this, you do dy. So what we got is from S, the area. This is dy, okay? And from here, you can tell you have two x values. The right hand side, the right x value, we find the difference of x. This is the difference of x, okay? So right hand side is the parabola is bigger. And we solve from here, we solve x equals, maybe not this one. From here, solve x equals 12 minus y squared over 4. So it's 12 minus y squared over 4 minus y from negative 6 to positive 6 and dy. Okay, so that's how you solve this one. You take it from the from here. You see, just from negative 6 to positive 2, you add all the small rectangle together. It's going to the area. The final answer is going to be 64 over 3. Okay. Does it make sense, everyone? Okay. You see, the number 2 is find the area. You use the vertical rectangle. Number 3, you use the horizontal rectangle. Find the area. Is the same area formula. S equals f of y minus g of y. From A to B, f of y minus g of y of dy. Okay, that's the number 3. Number 4, arc length. Arc length formula is S equals from A to B square root of 1 plus f prime of x squared dx. Okay, this one, I give this one y equals square root of 4 minus x squared, exact the same equation in the class. And I asked Taylor, I think I'm positive sure about, I think Taylor told me, this one, ask my question, what is the shape of this one? This graph, right? Okay, So if you remember that, I asked you what is the shape of this equation. So now I would like to ask everyone again, can anyone tell me what's the shape of this equation?
A semicircle?
Right here, yes. If we look at this, it's semicircle because y is positive. Okay, it's a semicircle. So now I ask you you can check your answer by notify the shape of the curve. The shape is a semicircle. For this one, its x is positive, so it's actually just quarter of a circle. Because it's from 0 to 2, x is from 0 to 2, and then the function is y equals square root 4 minus x squared. You can change that is you can check the x squared plus y squared equals 4. This is a circle equation, but it's just a y is positive, so it's semicircle. But now I only say x is from 0 to 2, so it's going to be just 1/4 of the circle here. Okay, and you can use. I said if you get the final answer, I'm not going to mark off any points. If you can read that out, and then the answer is you can get 1/4 of pi times 2r is 2 times 2. Wait, 2 pi r, right? Okay. So 1/4 times 2 times pi times r, which is 2, which is pi. If a final answer got pi, say, okay, this is the semicircle, I'm fine, okay? But I prefer you use this integral. I prefer use this formula to do this and check it back, use that. But I will not mark off any points as long as your final answer is right, if you got the same answer. Alright, so now, and mathematics is right. Now then, if we do that, if we use the formula, it's from 0 to 2, square root of 1 plus. Since fx equals square root of 4 minus x squared. So now I need to find a prime, the derivative of this function. Can anyone tell me the derivative of this function? Matthew, could you please help me with this derivative?
So you could rewrite square root of 4 minus x squared as 4 minus x squared to the 1/2 power.
Okay.
Then you would take down the 1/2, and then 4 minus x squared would be to the negative 1/2, which could go on the bottom, so it'd be 1 over to the group 4 minus x squared. Or like the square root, yeah.
That's it?
And the 2 on the bottom right.
So that's it?
So we bring it. Then it'd be times 2x.
Negative 2x.
Negative 2x? Alright.
Because it's minus x squared.
Yeah.
Yeah. And then you do that is basically you take the derivative in the base. The base is 4 minus x squared. The derivative of 4 is 0. Derivative of x squared is 2x. Sorry, derivative of x is 0 minus 2x is negative 2x. And then you cancel the 2. So this is negative 1 over square root of 4 minus x squared. So the answer is going to be 1 over, because the square is the derivative, then you square this. You square the derivative equals x squared over 4 minus x squared. So the answer is going to be x squared, 4 minus x squared, and dx. Okay, and then we have this answer right here. It's going from 0 to 2. You can simplify that. Common denominator, the answer is 4 over 4 minus x squared dx. Okay, here you can use the calculator to do this, or you can use the trig substitution to do this. It's fine. Okay, you can do trig substitution that x equals 2 cosine theta. Okay, so dx equals, just 2 sine theta. I don't want to deal with that negatives. So 2 sine theta is 2 cosine theta d theta. Okay, now I change the boundary. When x equals 2, then 2 sine theta equals 2. Sine theta equals 1. So theta equals pi over 2. That makes sense, right? When x equals 0, and theta equals 0. Okay, so now I'm done with the boundary. So just from 0 to pi over 2, square root of 4 over 4 minus x squared, so it's 4 minus 4 sine theta squared. Dx, which is 2 cosine theta d theta. Just change it, right? Change it and all the x into theta. So now we're going to have 0 to pi over 2. And then this is square root of 4 over 4 minus 4 sine theta squared. Can anyone tell me what that is? Maybe Luke, can you tell me? Is Luke here? Can you tell me what is 4 minus 4 sine theta squared?
Like what the integral of it is?
No, just simplify that.
Right. I'm not sure.
Okay, now I'm going to do one more step.
Is 4 cosine squared theta.
Oh, thank you, Lacey. Right, so if you factor 4 out, it's 4 1 minus sine theta squared. So it's 4 cosine theta squared here. Okay, so now you still have 2 cosine theta d theta. Okay, then you can have this is 0 to pi over 2, and then this is 2 over 2 cosine theta, 2 cosine theta. This canceled out, d theta. Okay, so it's just no, why the, oh yeah, so then it's just a 2 theta, because there's just a constant. Okay, just x dx, so just a constant, 2 theta from 0 to pi over 2. Then plug it in, it's 2 times pi over 2 minus 0, so the final answer is pi. Okay, thus you use the trig substitution, got is pi, or if you remember here, equals 2 from 0 to 1 square root of 1 over 2 square, 2 and then minus x squared dx. If you remember the formula, this one, okay, if you remember the formula, 1 over square root of a squared minus x squared dx. I would like to see if anyone remember the formula or not. Does anyone remember the formula of this antiderivative? Anyone? Does anyone remember the formula of this one? Arc. I give you 2 options, sine or tangent. It's arc what? Okay, then I'm going to give another one. 1 over a squared plus x squared. This is, one of them is arcsine and the other one is arctangent.
First one's arcsine.
First one is arcsine, very good. So it's arcsine x over a plus c. Second one is arctangent, so it's 1 over a tangent inverse. I just use that because I just have a small space here. Let's write another one. So this one is 1 over a arctangent x over a plus c. Okay. These formulas, I think when I do the review, I told you these formulas are important. Arcsine and arctangent we use a lot. So if you remember the formula, it's much easier as well. You don't have to do the trig substitution. You just need to plug into 0 to 2. I just write everything again, okay? 4, no, we don't have a 4 here. So just 1 over 2 square minus x squared dx. What you need to do is just apply the formula. So it's 2 arc sine x over 2 from 0 to 2. Now just plug it in directly. 2 arc sine 2 over 2 is 1 minus arc sine 0, plug in 0. Arc sine 1 is pi over 2 because sine pi over 2 equals 0. So it's 2 times pi over 2 minus 0, which is also pi. Okay. If you use the formula, you can directly get this. Or use trig substitution, you get a pi. Or you use the shape of that function, you get pi. Okay. So anyway, this is a good example of explain the math. You can do math in 3 different ways. Okay. You all get the same answer, the pi. So number 5. You find the volume, give you the solid y equals 49 minus x squared, y equals 0. And then you have the, this is the easy one, I think. Okay. Because you revolve that, it give you, that gives the volume generated by, okay. So it's like this. Okay. Basically, find the volume of this. You shape that. You can use shell method. If anyone have used the disk method, I think probably is okay too. Okay, if you use the shell method, what you need to do, you just use you revolve it with respect to y-axis. So it's 2 pi from 0 to 7, and then the height is y, 2 pi x. Sorry, the r. First, the formula is 2 pi from a to b, 2 pi r times h dx, right? So r is just the x, and the height is y values. Is the y values of this function. So it's 49 minus x squared and dx. Okay, I think the final answer is something like that, 0.5 pi. I'm not really picky on the final answer. If it's not the same, but you set up the model is the same, I put mark of 1 point, something like that. Okay. So I'm not really picky about the last answer, but if you make a right answer, for sure you're gonna have perfect credit, right? So this is how you set up the number 5. It's not really hard. Number 6, you find the volume. Okay, find the v enclosed by the function x equals 6y, y cubed equals 3x. So everybody asks you to do the shell method. So this one you have to use disk method or washer method. They are exactly the same, just to have pi r squared minus another small r squared. So now is this one like this. This is x equals 6y. Then because the y is positive, and revolve with respect to y-axis. Okay, so revolve this way, you're gonna have something like this, like that, right? Okay. So what we do is we set up this as a region like this. Okay. What you do is v equals pi from a to b, r, y. Since we are doing y-axis, so it's ry squared minus small ry squared and dy. So it's pi from, you find the intersection point for this one is 0, 0. This one is set up, those two equal each other. So you have y cubed equals 6y, and to solve this one, y squared minus 6 equals 0. So y equals 0, y equals square root of 6. So square root of 6. Okay, and y is actually 6 square root of 6. I don't need that. So it's going to be from 0 to square root of 6. Big ry, big is x is 6y square minus small r is the, this is big. You see the line is big, but then the small one, the left axis, this point is a function value. So it's y cubed then square and dx. Okay, this is how you find this one. And I don't remember the final the final answer of that, but it's not big problem if you set up this right. Number 7, and I think we can skip number 7. Everyone should make this one right. Someone probably get confused over m1 and mx, but I will mark off 1 or 2 points if you do that one wrong. Okay, but most people should do right, because we just do. It's very simple. You don't even have an integral for number 7. So number 8 we can skip, right? Because it's just w equals from a to b and fx dx. Well, you use that 350 equals 30 times x. Sorry, 30 times k. And you find k equals 35 over 3. And you just plug it in, so w equals from 30 to 60 and 35 over 3x dx. Okay, it's pretty simple. Number 9, we skip because you did that exact same thing, exact same problem right before the test, right? Exactly the same. The semi right corn like that. I did exactly the same problem. If I didn't even change the numbers. Last one. So a particular swimming pool at Princeton can be modeled by a shape as has a space bounded by y equals x squared, y equals 0, x equals 4. The pool has semicircular cross section perpendicular. Okay, it's semicircular. It's a semicircular cross sections, okay, that are perpendicular to x-axis. So you have this, you have 3 functions, 3 boundaries. So what I do, I just draw the picture. The formula for this one is pretty simple. V equals ax dx from A to B. Because you have the disk method is pi r squared, that's the area of the base. Then now it's semicircle, so the base is just a semicircle across the section. What do you have is y equals x squared, so y equals x squared here. And then y equals 0, which is the x-axis, and then x equals 4 is this one. It's x equals 4. Okay. What do you have is you cross any point, you have a semicircle like that. And you have to think about the 3-dimensional. Okay. So every point is a semicircle. It's a 3-dimensional thing. Okay, so 3-dimensional. So every point is a semicircle. You can see that? It's a semicircle at every point. Does it make sense? If you cut it, it's a semicircle. You cut it, it's another semicircle. So basically add all the semicircle together is going to the whole region. Then it's pretty simple now, if you know that. Then it's just from 0 to 4. For each one is a semicircle, so it's half of pi square. R. My question is, what is R? Can anyone tell me what is R of that circle? What is R of a semicircle? Anyone?
X squared over 2.
Just x squared. Wait, just x squared. No square.
The diameter?
No, you can see that. You cut it a semicircle, but if you cut it at a semicircle, so which means the height is a radius. Does it make sense? Because you cut it down, like you cannot. If you cut this is the height. It's just a semicircle. You see, there's a bottom part is another half. So if you cut that, it's a semicircle. So it's like this. The height is a radius. Then there's radius. This is radius. Does it make sense?
Yeah.
It's 3-dimensional. You cut that. The height is actually the radius, and you have another half circle is in the bottom like that. And then this is a half circle, and the height is just the height. Y values is just the radius. So it's pi r squared over 2 dx, and that's how you find the whole volume. And then that's it. It's not. Some students forget the pi. You got x squared. If you use x squared, if you do x squared, it means the cross section is actually a every part is a square. If you cut it, every part is square, then it's x squared. Its semicircle is pi r squared over 2. Okay, so that's how you do the last one. So this is a test, and I have not finished the grading yet, and it's not really bad. I think everyone should pass it for sure, but I will see. We'll see. Okay, and let's continue with our trigonometry integrals. We don't really have a lot left. We finished most of that. So trigonometry, we did in the previous class. We stopped at the tangent. So now let's continue on the trigonometry. is 8.3. And I continue. So now we did sine and cosine in the previous class. Now we're going to look at some problem of tangent and cotangent. So next one, if we have something like this, secant x power m and tangent x power n dx. Okay, for example, if I have something as secant x squared of tangent x dx. Okay, if I have a function like this, previously if you know that if you have a sine x squared and cosine x dx, what do? You change that cosine x dx as d of sine x, because the derivative of sine x is cosine x. So change that into d of sine x. Then you can use the u substitution as u squared du, u equals sine. Okay, and then you got u cubed, which is u cubed over 3 plus c. Basically, complex it back is sine x cubed over 3 plus c. Right? That's what we do. So now, if I have secant tangent, you do exactly the same thing. Okay. So what do we need to do? We need to what we need to know is the two derivatives. So first is the derivative of tangent. Oh wait, just derivative of tangent. What's the derivative of tangent x? Can anyone tell me? What's the derivative of tangent x?
Secant squared x.
Very good, thank you. Secant x squared x dx. Okay. And then, what's the derivative of secant x? Anyone? Is secant x tangent x dx? Yes, did you check it? Okay, so you're going to use this tool a lot for the tangent part. We don't do the cotangent a lot because secant and tangent we use more. Okay, so secant x tangent x dx. Most likely we're going to use this tool. You know why do I do that? Why do I write this way? Previously we do this. We write it as d of dx of tangent x equals secant x squared. Previously, this is what we learned in the calculus 1. Now I just multiply the tangent x on the other side. The reason I do that because you are going to have this a lot, because this is what I'm going to substitute, right? So it's more naturally as you have a dx here. So here you can see that for this one, can anyone tell me what do I do from here? So I do have a tangent x here, we do have secant square, I have dx. So how about this? Tangent x, I combine the secant x squared dx, combine these two together. I will have tangent x squared and d of, because you have this, d of tangent x. And then you substitute u equal tangent x. And the whole thing will be just u squared du. So the final answer is going to be u cubed over 3, which is plus c. Got that? The answer is going to be tangent x cubed over 3 plus c. Okay. Oh, my bad. Why do I have the square? Because the problem, I don't have a square. Tangent x, right? So I just have u. My bad. But it doesn't. When you do that, you have to pay attention. But the whole method of thinking is right. Okay. Tangent square over 2. Okay, so this is the tangent secant. By the way, have you all finished the homework? Because 2 homeworks have required this method. I will extend the homework 1 more day. It's going to be due tonight at 12 o'clock, okay? I'll extend it 1 more day. If for those who has not finished it, for the last 2 questions, I think it's tangent secant. So you can finish that today, okay? I'll go back and extend the homework. If you do not finish it, it's going to be until 1 more day. So tangent x over 2 plus c. Alright, so this is if for secant xm tangent xn dx, okay? So this is, we can do a summary. If the power of secant is even and positive, if the power of the secant is even and positive, so we save a secant square factor, okay, and convert the remaining factors to tangent. Okay, convert the remaining factors to tangent. That's what I would do. Okay, so this is the example of that. Because the secant is even, we just take that even into tangent. The rest is fine. So let's look at one more example of the same thing. Tangent x squared secant x power 4 dx. We have the secant is even, which is perfect. From the method, I need to save the secant square, take 1 over the secant square out. So secant x squared, another secant x squared, and dx. From here, I should combine these two as d of tangent. My problem is, I have no problem of changing this u into d of tangent x. But what about this part? Can you tell me? Let me call someone. Anyone? Maybe let me call a name. Any volunteers? Because you cannot see my... excuse me?
Can we substitute the secant squared x for like a 1 minus 2 tangent or something like that?
Oh, that's a perfect idea. Yes, you did very perfect. Thank you. Yes. It's tangent x squared of secant square is 1 plus tangent x squared. Okay, d of tangent x. Do you prefer to see my face too? Like I can, I'm not sure how is it better. Like just I put this and right here, I can see my little face on the screen. So now it's going to be tangent square. And you can distribute that and plus tangent x power 4 and d of tangent x. Let me try it, see if it works. Okay. The next time you can still see me. Tangent x. And then this equals, if you distribute that, and then this is u, this is u4, this is u, so just do it directly. So it's tangent x power 3 over, if you see my face, if this is not really working very well. So tangent 3 over 3 plus tangent 5 over 5 plus c. I skipped a little bit in here. Okay, you can do u equals tangent x is u squared u4 du. That part you can skip it. That'd be okay with you, right? This is u squared. You do u squared plus u4 and du and u cubed over 3 u5 over 5. So that's not a big problem. Okay, Second one, this is for even. You see secant is even. Now what if second case? If the power of tangent is odd. If the power of the tangent is odd and positive. Okay, and we can, for example, basically you have something like this: secant x power m and tangent x to 2k plus 1 and dx. This equals secant x m minus 1 and tangent x squared to power k and d of secant. Okay, let's look at an example. I don't want to do too many m's in case you feel confused. Just example. If you have tangent x power cube and secant x power 5 and dx. Basically here, you have the secant is not even anymore. It's odd number. You cannot do that secant again. And you can, if it's even, you just take square out and then the rest even as 1 plus tangent. Now it's not even anymore. So what we do, we can do tangent x to power square and the secant x power 4, and you save tangent x, the additional tangent x and the other secant x out, dx. This is 5, this is 4, this is cube, this is square, so I have additional 1 for each here. Okay, these three together is d of secant. So tangent x squared, secant x power 4, and then is d of secant x squared, d of secant x. Everyone, does it make sense? So what do you think I need to do here? Because this is secant, this is secant. I have to change that tangent to secant, which is not problem at all, because tangent is x squared equals, can you tell me tangent x squared equals what? Convert into secant. Okay, this is that is 1 minus secant. In different idea? Is 1 minus secant or secant minus 1? So secant x squared equals 1 plus tangent x squared should be secant squared minus 1. Okay, but it's not a big problem. You just do, once you write down this formula, you'll be fine. d of secant x. Now we distribute it out is secant x power 6 minus secant x power 4 and d of secant x. Well, just to use substitution again, this is u, this is u, this is u. So it's u7 to over 7. So it's secant x power 7 over 7 minus secant x over 4 of 5 over 5 plus c. Does that make sense, everyone? Okay. That's great, right? Okay, so next one, if there are no secant factors. Okay, so next one, if there are no secant factors. Okay, the tangent is even. The tangent power is even and positive. What do we have is a tangent n. I'll just give you an example, n dx. And you can take a square, tangent x and minus 2, and secant x squared minus 1 dx. Okay, for example, wait, it's not even. How tangent is even and positive, convert that into that. I think it's okay. So example, you have tangent x power 5 and dx. Okay, we don't have any secant here. What do? We change that into tangent x squared and tangent x cubed dx. The reason I do that, because I can have something, I can reduce the power here. So here, tangent x squared can change into secant x squared minus 1 tangent x squared, tangent x cubed dx. You can continue here, these two, as secant x squared tangent x cubed dx, and minus tangent x cubed dx. You see, here I have a secant, I make out a secant out. I can continue make another secant out here. So this one, I have secant here, so it's tangent x cubed d of tangent, which is perfect. This one, I continue make another secant out. Okay, and you can make this one as secant x squared minus 1 tangent x dx. Okay, so this is just a regular tangent x over 4 over 4. This one, which is perfect, I have a secant x squared, I make a secant x squared out again. So secant x tangent x plus tangent x dx. And then this one is perfect because I can change that in d of tangent again. So it's tangent x power 4 over 4 minus, this is just a tangent x dx. So this can be just tangent x d of tangent x, because secant is d of tangent x, right? So the whole thing is going to be just tangent x squared over square. Antiderivative of tangent x is minus ln cosine x. That's just a formula plus c. Okay. If the tangent x has higher power, we don't have secant, you can take out a square and make a secant out. Okay. So I think we're going to stop here today. Tomorrow we're going to do the integral by parts. Next, let me see. Or we do trigonometry substitution. Probably I'll do a few more examples about the tangent and secant again, and then we'll do trigonometry substitution for 8.4. Okay, so you should expect to get a grade by today. I'm going to finish the grading after this class. And if you have any question, just feel free to send me an email. Okay.